Day 182 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 182, y'all. So we're about to finish up our portion of doing the hash maps and dictionary problems of the LeetCode, just the LeetCode hash map and dictionary problems. And then after that, we're going to move on to the top 150 questions, interview questions. So get excited about that. This probably will be our last dictionary or hash table problem. We might do one more tomorrow, just do one more for good luck. We'll see when we get there. But yeah, we're still going. I hope y'all are still staying disciplined and still staying consistent. And I hope y'all are keeping up with this channel, because we're going to be here every day learning and getting more knowledge, and then taking one more step further down our path on our LeetCode journey, y'all. So just keep coming, keep checking out this channel, keep pushing through. Don't give up, y'all. Just keep going. We're not giving up. I'm here to help encourage you to keep going as well. We're all in it together, and we're all here to learn together and push each other to keep going and keep learning, y'all. So I hope y'all aren't feeling burnout yet, because we have a long way to go. We're only about 6 months in, meaning we still have at least 9.5 more years to go, y'all. You know what I'm saying? We got to at least do 10 years of this straight just to get our 10,000 hours in. So get ready for that. Get mentally prepared for that. Internalize that. Wrap your mind around that. And let's get started on the question today. But before we get started, y'all, don't forget. Bring a mouse, bring a mouse, bring a mouse. Bring your mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we can push this content out to a broader audience, y'all. You know what they say, Swift is the new Python, and it's up to us as Swift community members to push this Swift content out to as many people as we can find that will watch it, y'all. We're trying to get as many people as we can interested in learning about the Swift programming language, and one way we can do that, y'all, is to share this content, so your support is appreciated when it comes to that. Now, with all of that being said, y'all, let's get into the question. And today we have question number 1331, rank transform of an array. The difficulty level is easy, so you already know how we do on this channel. We're going to keep the solution as simple and easy to understand as well, because we're all here to learn something. And if you don't understand the solution at the end of this video, then you probably didn't learn anything, and that is not what we want, y'all. So let's get into it. The question says, given an array of integers R, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. Rank is an integer starting from 1. The larger the element, the larger the rank. If 2 elements are equal, their rank must be the same. Rank should be as small as possible. So let's break that down. Let's look at example 1 so we can break that down. Example 1, excuse me, y'all. In example 1, we have the input R equals an array of integers 40, 10, 20, and 30. The output is 4, and the output is also an array of integers 4, 1, 2, and 3. Explanation says 40 is the largest element, 10 is the smallest element, 20 is the second smallest, and 3rd is the third smallest. So let's break that down. So in the input, we have 40, 10, 20, and 30, right? So 40 is the 4th largest, so we put a 4 right here for 40. That's its rank. Its rank is 4. 10 is the smallest. Out of all of these numbers in R, 10 is the smallest number. So its rank is going to be 1 because it's the smallest, right? Then 20 is the second smallest, so its rank will be 2 because it's the second smallest out of all of these numbers. Then 30 is the 3rd smallest, so its rank will be 3 because it's the 3rd smallest, or 3rd greatest out of all of these elements, which is why 40 is 4, because out of all of these 4 elements, it ranks number 4 because it's the largest element, right? So that's how this works. We're just corresponding each element or each index in the output is going to correspond to the rank of or the rank in sorted order basically of R, right? So whichever is the smallest number in R is going to have a rank of 1. Whichever is the largest number in R is going to have a rank of r dot count, right? So since in this case r dot count would be 4, since 40 is the largest number, that's why the output is 4, because there's only 4 elements to deal with. So let's look at example 2, where it's a little bit more tricky, but it's not that difficult to understand either, right? So the input r is equal to an array of integers 100, 100, 100. All of these numbers are equal to each other, so the output is 1, 1, 1, because it says right here, what does it say? What does it say? The following rules. If it says right here, if 2 elements are equal, their rank must be the same, right? So right here we have 3 elements that are equal, which is why their rank is the same. They all rank number 1 because they're all the same. They're all equal to each other. So let's look at example 3, where we have a little bit more elements, but it's the same principle. It's easy to understand, y'all. Let's get into it. So in example 3, we have the input r equals an array of integers 37, 12, 28, 9, 100, 56, 80, 5, and 12. And y'all already know we want to rank these elements from least to greatest, and the smallest element is going to be ranked number 1. The largest element is going to be ranked whatever this count is, right? So this count is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the largest element will be ranked, well, actually, as you can see, we have 2 12s, right? So it's not necessarily going to be the r dot count, because in this case we have 2 12s, so r dot count would not apply. So in this case the greatest element is going to be 8, because there are 9 elements up here, right? But 2 of them are the same, so we don't have to include the 9th one because their rank will be the same, right? And in this case both are ranked 3, meaning they are the 3rd largest, right? So let's go through it just to make it make sense. So 37, that's the 5th largest element, so we put a 5 right here. 12 is the 3rd largest element, so we put a 12 right here. 28 is the 4th largest element, so we put a 4 right here. And 9 is the 2nd largest element. The 2nd smallest element. So we put a 2 right here. 100 is the largest element, so we put an 8 right here. Excuse me. Put an 8 right here. 56 is the 6th largest element, so we put a 6 right here. 80 is the 7th largest element, so we put a 7 right here. 5 is the smallest element, so we put a 1 right here. And 12 is the 3rd smallest element, so we put a 3 right here, right? So we're just ranking these elements starting from 1 smallest to greatest, right? So that's all we're doing. I know I used the r dot count example when I was using it up here, but as we can see, that isn't necessarily going to work, because we may have 2 of the same elements, where in this case, it's 2 12s, or in this case where it's 3 100s. It's 3 100s, the count might be 3, but all of the outputs are still 1 because they're equal. So ignore that r dot count reference, because that doesn't really apply in this question. But it's still simple. We just have to rank these from top to bottom, smallest to greatest, and just append their rank in the output, right? So now that we understand the question, let's get into the fun part, the part that all keeps us motivated to keep going, the part that's gonna all get us this money that we're trying to get, and the part that's gonna bring us the peace and joy and happiness that we all want, the code. First thing we're going to do is we are going to declare a variable called hash map, and we're going to set that equal to an array or a dictionary of integers, right, like so. And we're going to initialize it with we're just going to initialize it with some parentheses like this. Then we're going to come down here, we're going to say for, open up the parentheses, index, comma, I, and set. So what set is going to do, that's just going to get us the unique elements, or it's going to take all of the elements and just print them uniquely so that we have 1 of each element. So we're going to turn it into a set R. Then we're going to sort it, dot sorted, because we want to rank them from smallest to greatest. So we're going to sort it, And then we're going to say dot enumerated because the enumerated is going to get us the value and the index. So as an example, the enumerated will return this 37 and it will let us know it's at index 1. So say 37 at index 1 basically. And this was return 12 at index 2. And 28 will be 28. Oh, excuse me, y'all. Rewind. My bad. It's a lot going on today. 37 would be index 0. 12 would be 12 at index 1. 28 would be 28, which is at index 2. So this enumerated is going to get us the index and the value of that index, right? So we could put some parentheses there. Open up the brackets. We're going to say hash map I, square brackets I, right? Then we're going to say equals index plus 1. Then we're going to come outside of that for loop. We're going to say declare a variable called rank, set that equal to an array of integers, initialize it, excuse me, y'all, with some parentheses like that. We're going to say for I and R, open up the brackets. We're going to say rank dot append, open up the parentheses, hash map, open up the square brackets, I, comma, default, 0. Then we're going to come underneath that and we're just going to say return rank, y'all. That should be all she wrote. Let's run it, make sure it runs how it's supposed to. Let's see. Okay, it's accepted. So let's submit it. Submit it, make sure it stays accepted. Let's see. Ooh, 19 milliseconds beats 60% of users with Swift, y'all. Not too bad. We got to get those numbers up, but we can do it, y'all. We just have to keep coming back and keep learning every day, y'all. So I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then. Peace.